Welcome to how to make your own homemade Blu-ray violet laser. This is one of my most recently assembled machines here. I built this using scrap and recycled components that I mostly got for free, but there were some costs involved. So, anyways, I'll be doing a brief overview of how I put this together, how it works, and what you can do with it. Alright, so just right off the bat here, I just want to make a disclaimer. If you're new to electronics or don't have any hands-on experience of electronics, then building and tinkering with your own laser should not be your first project. But if you're interested in the hobby of lasers, then I definitely recommend picking up a pair of certified laser safety glasses. Before you even buy your first laser, you want to buy a pair of protective safety laser glasses. And to do that, you want to determine the wavelength of the laser that you're operating with. So in this case, I'm using a 405 nanometer violet laser diode that I got out of a broken Blu-ray player. So these will work great because they're rated for 190 to 540 nanometers of laser light with an optical density of 6. So these are quite extensive in terms of their protective range. Not only will they block the velocity of the beam that impacts the plastic lens here, but it will also absorb the wavelength of the emission, so it doesn't enter your retina. Now, like I said, some of your laser projects are going to come at a cost, so most of the components that I used to build the laser were mostly free. We'll get to that in a few minutes, but this pair of laser safety glasses that is certified I paid $50 for plus shipping. So keep that in mind when you're going to be wanting your own lasers. But this is exactly what I would recommend for using this type of laser. These will be quite effective. Now onto the construction of the device here. For power, I'm using a computer power supply rated for 300 watts. And I got this for free from an old computer. As for the driver, I'm using a LM317T semiconductor, and I paid for like $2 or $3 for this off eBay. And I have the input of the computer power supply connected to the positive input here. And I have the input short circuit to the heatsink, as well as a short circuit path from the input to the adjustable pin. And then the adjustable pin is connected to the positive output pin via this load here, which is just a 33k ohm resistor. And the positive output lead is going directly to the positive pin of the laser diode, while the negative output of the power supply is going to the negative pin of the laser diode. Here is the laser diode assembly. As you can see, it's quite simple. I left the laser in its original form factor to reduce any damage that would come from removing it, because it can't always be done, so this is often the best way to get around that. This is known as the PPX5 laser diode, and it is commonly found in Blu-ray players. And I have it thermally bonded here to this heatsink, and that should help dissipate much of the heat that will be produced during the operation of this laser. And of course, I'm using a convex lens to help converge all of that laser light to a tiny point. Okay, now about to fire up the laser here. And before I do that, I want to make sure that I have my laser safety glasses equipped. And once I've got that covered, I want to make sure that my environment is free from any possible hazards, such as other people, animals, exposed windows, and intense reflections. Now that I've done my safety check, now I'm going to fire up the laser. As you can see, it's quite bright. So this laser is currently in a converged state. So there is a focal point approximately half an inch out from the laser output there. And not only that, it has a far down range. So this laser can exceed at least several feet away from the output emitter before diverging out into a highly divergent state. Now let me show you what this laser is capable of doing to certain materials. Now let's see what this laser can do to a piece of vinyl electrical tape when I stick it in the focal point of the beam. Oh, it shot right through. Let's do that again. Shot right through. Alright, one more time. Shot right through. Amazing. Let's see what happens when I take some paper that's been covered with green marker and stick it at the beam there. Let's see what happens. Oh, look at that. That's cool. Even just the white paper itself will fluoresce against the laser there. Alright, let me show you a few tricks I can do with this laser using more fluorescence. So here I have some highlighters, just basic household materials. Now watch this. Watch as I stick the highlighter, which will fluoresce quite powerfully against this near UV laser. Near UV lasers are commonly known to excite the fluorescent state quite profoundly. So watch this. Look at that. Definitely wouldn't be looking at that without no laser glasses on. Let me show you this other one here, green. Very bright. Now I also have here a few jars that I've made using highlighter materials. These are custom made fluorescein jars, so let me just stick this into the beam here. So currently the laser is exciting the chemicals in this solution here, and is actually effectively pumping this jar of fluorescein here, as well as this one. Alright, now for some fluorescence at night. Here's that orange highlighter. And the green one. Two of them side by side. You see the ship there? Orange again. Some white. More diffuse there. And a bit sharper there. Let's flip this side. A bottle of isopropyl alcohol. You see the shift there. Jar of fluorescein. And that green one again. Punching through more electrical tape. Alright, so that concludes this video. I hope you enjoyed it, and hopefully you learned some things about how to build your own homemade laser device. And yeah, so stay safe and have fun.